All right, we're seeing quite a lot of folks jumping into the room, so this should be a great session, a lot of interest on this topic, and we'll get kicked off right away. So, Cecil and Corey, let's see your beautiful faces here. I'm really excited to have Cecil and Corey join us today for this session on API security and why it should be a top priority for next year for 2022. Joined by Cecil Pineda. He's a CISO at R1. If you don't know Cecil, you should get to know Cecil. Just an amazing person, incredibly knowledgeable, and just all-around great guy. Founder of CISO XC, which I recommend everyone go take a look at and learn. If you're a CISO, this is a fantastic community to be a part of, to network, to learn. So really grateful for Cecil to join us today. Also joined by Corey Ball, who's a cybersecurity consulting manager at Moss Adams, pen tester by day, author of Hacking APIs by night, or hopefully most of those nights are now behind you as the book is being released as we speak. So for a lot of you in attendance, we're sending over free copies. At the end of the call, we'll share how you can also get a free copy if you're interested. It's a great read, I can tell you that. So with that, and I'm Dan. I'm head of marketing and business development at AppySec. I'm really pleased that you're all here joining us today for this session. There will be a recording we'll share out if you've got colleagues who weren't able to make it today. And so with that, Ethan, let me hand it off to you, and let's kick things off.
Hey, thanks, Dan. And could you drive the presentation?
Yeah, absolutely.
Yeah.
Oh, sorry. Here's the little plug for Cecil's book. I inserted this fancy little animation and I missed it. So there you go. Make sure you check out Hacking APIs, and if you're interested, follow up with me and we can get you a copy. And with that, there you go, Cecil.
Okay. Thanks, Dan. And just FYI, guys, my internet is down, so I'm in my kitchen. I have a good, strong 4G, 5G reception.
Oh, and
I lose you in case
as you say that, we lose you. Are you still there, Cecil?
Yeah. Sorry about that. Just in case I lose you, I'm just gonna turn off my video. 4G and 5G right now. Sorry about that. I didn't anticipate this. And if anyone is probably familiar, Akamai and AWS West is down also. So there's a lot of services that are not available right now. Anyway, let me start. Thank you, Dan. Yeah, APIs are everywhere. If you look at your environment, you will not, you'll be surprised if you start looking at the APIs you develop that you use. You also interface with maybe dozens or hundreds or even thousands of APIs, depending on the size of your organizations. So according to Akamai, 83% of all internet traffic is now API, and that's not even surprising, because if you work in IT today, you know that all your apps interconnect with other apps. APIs are so important in our organization because APIs reduce the code base. It reduces it decreases your efficiency to connect to other applications, internal and external. It simplifies the way you develop your software, because you don't have to rely on different applications. You basically use those APIs to interconnect with web application, with mobile applications, and internally to your application servers, to your database. So today you could see that a lot of our traffic today are mostly our API traffic today. Then the next, could you press that? Yeah. In the next few slides, I'm going to show you some of the events or incidents that IBM is reporting today. This is from the IBM data breaches that they produce annually. I encourage you to look at that. And the last one is, and in 2022, so my fellow CISOs, I know a lot of you, same with a lot of CISOs around today, we mostly focus on mobile and web applications today. So it's really important for us to ensure that those those APIs behind those mobile and web applications needs to be secured. So I want to show you on the next slide some of the risks that and that we have for APIs. So if you look at all the APIs today, your companies, if you go to the most common way to find out if you're using APIs, go to api.yourcompany.com. That's an API that you have that you use to, with your partners, with your vendors, and they are published and they have detailed documentation. Just imagine this is an open book for the hackers as well. These are essentially almost like backdoors for your company. That's why you have to make sure that they're protected, and you have all the recurring testing to make sure that you don't have API vulnerabilities. The second one, with APIs today, it adds significant attack surface to your applications data and organization, and to your partners as well. Because if you don't secure API, that's a target for most hackers. And later today, Corey is going to share to you, how hackers, exploit APIs. Yeah, and next slide, Dan.
Oops, there we go.
Yeah. So as you can see here, I want to emphasize the two areas here: the mobile app and the web app. And 9 out of 10 organizations today, they focus their testing on those two areas. And not really a lot of people are doing API continuous vulnerability testing and assessments. And one of the, our sponsor for this webinar, APISEC, they do those things. And later today, later at this session, Dan will explain to you how that works. So, but anyway, as you can see here, this very example, you can see that APIs have direct access to sensitive data. They connect to application servers, to your microservices, to your database applications. So they have to be really secure. And a lot of APIs, they're over permission. Some of them you don't even realize they're probably leaking credentials. And you've heard so many incidents that happened in the past few months that a lot of organizations today are exposed because their APIs were leaking credentials or certificates. So, and next slide. So we get 5 here. Dan, you could show all of them, and I'm very interested. This is really interesting. These are just some of those API breaches that you heard, and I really like this the Venmo one. I was just reading the article on Wired about this Venmo. So if I can send you the link, the hacker said he was able to scrape millions of transactions on Venmo by just by using the official API that Venmo is publishing today. So you can see here all these companies. Look at LinkedIn, 700 million users, and if you need the link to those stories articles, I can send them to you shortly after, or Dan could share those articles. Dan, okay, next one. Before I turn it over to Corey, to my fellow CISOs, a lot of us, we mostly focus on securing the front end, and that's good. However, as you could see here, APIs connect to a lot of parts of your organizations. They need to be developed in a secure manner. I'm not sure if Corey is gonna. We don't have a lot of time to discuss about API security frameworks, but I know Corey is gonna touch a little bit on that and how to test APIs. Corey? Thank you, Dan. Thank you, Corey.
Yeah.
I'll be here.
Thanks, Cecil. So before I jump in, I just wanted to go over why I wrote Hacking APIs, and there were 3 big contributors to that, which were the OWASP API Security Top 10 had just come out in December 2019, and that's about the time that I had just started forming ideas about writing the book. Moss Adams, where I'm a cybersecurity consulting manager that leads our penetration testing efforts, was getting an uptick in requests for API-focused penetration testing. And partner there, Kevin Villanueva, had voluntold me to become a subject matter expert on API security testing. So anytime I take on a new challenge like that, I typically will find whatever blogs, YouTube videos are out there, any conference talks that are available. And the other thing I always do is go on Amazon or go to nostarchpress.com and see what books they have on the topic. So I went on Amazon, typed in hacking APIs, and there was nothing out there. And I'd gone to a few cybersecurity conferences around that time after I'd been researching the topic for a bit. And I just started asking other expert pen testers out there, you know, what are you doing for API security testing? Where did you get your knowledge? Are there any good sources for our team at Moss Adams to learn about it? And no one had an answer. A lot of them had, you know, maybe a person on their team that focused on that, but there really wasn't any sources for good information on pen testing or security testing of APIs. So as soon as I had learned, you know, that there are no books out there, other experts don't know what to do, I already had close to 100 pages of notes that I had taken. I reached out to No Starch Press and said, hey, you know, would this be a good idea for a book? We went back and forth, and that was sort of the origin story there. But one of the biggest factors was actually, I had learned about the USPS data leak, even though that was in November 2018. I learned about it around that time, December 2019, early 2020. And what's the most interesting part of that data leak is about a month before it was released on Krebs, there was a vulnerability assessment performed by the Postmaster General. And this vulnerability assessment is public. You can go out there and check it out. Really interesting because a month before this huge 60 million user data leak of private information was released, it had been assessed. And so when you go through the report, you can see, you know, generally the testers were focused on the web application. They had mentioned there were a few authentication issues, but if you do like a quick search through the entire report, there's not a single mention of the API, which was central to the new release, which is why, you know, part of the primary reason they're actually testing it was for that. The Appendix A of the report is interesting as well because they go into the tools and techniques that were used to test it. And some of the tools, you can go and actually use those tools to this day, and they'll provide you with false negatives, essentially saying that there's nothing wrong with the API, even though it's extremely vulnerable to an attack. Essentially, with the USPS data leak, you could go on as an authenticated user, which anyone could become an authenticated user, and there were authorization problems. So as user A, you can go out there and search for user B's information. You could search by a physical address and find everyone else's information that was related to that address. If you were in an apartment building and you put in the address, anyone else that was in that apartment building at the same address, you would see their information as well. So excessive data exposure there too. So you can go to the next slide. So 2022 API risk, this is out of the book, Hacking APIs. Many APIs lack the security controls that other attack vectors have in place, making them the equivalent of the Death Star's thermal exhaust port, a path to doom and destruction for businesses. It seems a little bit dramatic, but seriously, like these are pipelines that are allowed through the firewall, and if they're not tested properly, they could be vulnerable essentially by design with business logic flaws, or similar to USPS, like your authenticated user, but there was no restrictions in place for authorization. So you can go on and what a normal criminal attacker would be going after could be the data, right? So if normally you'd have to get past the firewalls, you'd have to have exploits at your hands in order to gain access to a single system. Once you have that access to that system, then you could pivot to other systems on the network, hoping to find the database filled with private user data that could be valuable on the dark web. But instead of doing that, you could learn how to use the API, and if the API is not protected, you don't need to do any of that fancy hacking. Instead, you can use the API as it was designed and make queries for other users' data and get handed everything that you were looking for from the beginning. And so without proper testing, it's leaving these APIs exposed and just ripe for the picking. And that's where you get, Gartner years ago saying that 2022 is the year that APIs are going to be the leading threat vector. And I think that's already true with criminals. The API data breaches are exponentially growing. And some of the key factors going into 2022, we've all experienced the great reshuffling. So go ahead and go to the next slide. With the great reshuffling, one of the major issues there is that developers that know, they have the tribal knowledge of what's going on with the APIs. They know the inventory of APIs, and perhaps that's not documented. And that alone is going to lead to a growth in one of the API security top 10 vulnerabilities that's lower on the list, which is improper assets management. So this is essentially the equivalent of an unsupported software vulnerability. So these APIs are out there, a certain amount of developers know about them within an organization's network. They're currently supporting them, updating them, making sure any vulnerabilities are patched. But then the great reshuffling happens and something like 60% of developers are considering a new career or switching positions. So they leave the organization, and all it takes is one developer really, but when you have that many leaving, it's going to leave these APIs unsupported. The APIs are going to be forgotten about, and they're going to be vulnerable over time. New vulnerabilities are going to be discovered, and perhaps on the APIs that are supported, that's updated and patched. But on these APIs that are unknown to the organization, they're just going to be sitting out there, and criminals easily going to be able to take advantage of those. So with that in mind, you really need to make sure that APIs are managed throughout the lifecycle and that they're included in the inventory. So you need to make sure that the API is documented and that they continue to be supported, whether or not your staff is changing. The other one, BOLA, it's already #1 on the API security top 10 for good reason, which is API providers do a great job at making sure that users are authenticated to the API. So they want to make sure, legitimate users have access to that. But the #1 thing that's overlooked is authorization and making sure that user A, company A, can't access company B's resources. And it's one thing to sort of hide the resource IDs, but the important factor there is that user A isn't able to access, interact with, alter user B's resources at all. One that's not on this list that continues to be a leading vulnerability, business logic flaws. And that's where API security testing is so important, because as an organization, you have all these business reasons that you want your API to have all these features and make accessing data easy and convenient for legitimate users. The problem is if those aren't tested with an adversarial mindset, so seeing and thinking of ways that a criminal actor could use a feature to their advantage to take another organization's data or to take advantage of your systems. Anything that's really based on trust without the technical backing is going to be vulnerable to that sort of attack. I go ahead and go to the next slide. So if you want to check out, there's a really good report that was just put out by Rapid API called the State of APIs. You can go to stateofapis.com. Really interesting. They interviewed 2,200 developers across 130 countries. And for me, the most interesting part of that report is they had asked, out of all of those surveyed, who's thinking of doing API testing? And there's some high percentage, maybe 94% were thinking of doing API-focused testing. But they asked a follow-up question, which, what type of API testing will you be doing? And out of those, there's a lot of functional testing, integration testing, acceptance testing, but way down on the list, a horrifying number, which is security testing. Only 4.3% of those surveyed were planning on doing API security related testing. So that's a huge amount. If that represents the industry at all, that's just adding fuel to the fire of Gartner's prediction. So the APIs are a leading attack vector for criminals. I've already covered that. They're out there, they're vulnerable, they're not being tested, and the APIs are often the path of least resistance. So when an attacker is looking at the attack surface of an organization, they'll see that the firewalls are in place, the authentication in the web app graphical interface is locked down. But sure enough, just like many other organizations, the attack surface has greatly expanded from introduction of new APIs. And with those not being tested, that's just going to be the easiest way into the crown jewels of every organization, which is that private data. So the final thing here is effective testing is critical. And if we think back to the USPS data leak, that was tested a month before a leak of 60 million instances of private data. And so it's not just that you're testing APIs generically, but you're using the right tools and techniques that will help your API security vulnerability management program, really do a good job at preventing these sorts of attacks. Next slide. I think that's it for me, actually.
All right. Thank you there, Corey. I think you really make a compelling case for the need for security testing of APIs, and it certainly brings to mind a few challenges that come up with this. I mean, you need to have really specialized set of skills. You need to understand not only how APIs get breached in the real world, but also a deep understanding of the inner workings of your API and your logic. Hey there, Corey at Cecil. I'm going to go through a little bit of kind of the landscape of API security. A lot of people ask us, what are the different approaches that exist? And really, there's lots of different ways to cut it and slice it, but really there are, they sort of fall into two buckets, right? There's a pre-production approach to securing APIs and an in-production or a runtime approach to securing APIs. And as Corey kind of really, highlighted here, right? The main focus on pre-production is testing, right? Really validating, pressure testing those APIs, not just for common security vulnerabilities, but also for those business logic loopholes, unanticipated uses of the API that can result in data being accessible. In production, we're looking at live traffic monitoring, right? So very much like a SIM-like approach or a firewall-like approach of watching the live traffic and trying to identify good from bad. The benefits of these approaches or some of the capabilities of the approaches, of course, with testing, it's really about a preventative security approach, right? It's looking at that API, that application, and uncovering those logic flaws, the security vulnerabilities, those loopholes that can permit data to leak out in unexpected ways. Whereas for production, the use case tends to be more like, help me uncover what APIs even exist. Certainly, the vast majority of organizations we talk to, they absolutely know what their core APIs are, the APIs that power their mobile apps, their web apps, their e-commerce site, their transaction engines. But are there other random, lesser known APIs that exist? Traffic monitoring can give you visibility. From a protection perspective or a detection perspective, this approach generally relies on anomaly detection, which means establishing some sort of baseline of what normal traffic looks like, and then identifying deviations from that. And that is a very challenging thing to pull off. If you build a very tight baseline, you're going to open yourself up to an awful lot of false positives. If you have a very loose baseline, you have a lot of false negatives. Whereas on the pre-production side, the challenge is how do you really accomplish this type of sophisticated testing? Corey, you talked about fancy hacking for the Death Star approach, but testing your API is not an easy thing to do, right? Looking for SQL injection attacks, not so hard. Looking for BOLA or those authorization type of attacks is tricky. And so when we look at, if this wouldn't be a proper API security webinar without a requisite OAuth top 10 chart. And what you'll see here is, the differing approaches have differing levels of coverage. But when you look at sort of the top half of this list, that's where the bulk of the real breaches are taking place, right? So Postal Service, that is a classic example of a broken authorization vulnerability, right? User A was able to authenticate to the API and then pivot and access user B and 60 million other people's information. If you look at Peloton, right? They had an unsecured endpoint that provided access to all 4 million users. So I was included in that one. I was probably in the first one too. Excessive data exposure. Cecil talked about Venmo and how there was an API that not only returned some high-level information, which was the intended purpose, but actually revealed all the details of all these 200 million transactions, the to and from, the description, and so forth. So an API that was designed to return all the details when really the use case only required high-level information. At Instagram, an example of rate limiting, where you could reset your password by guessing any of 1 million reset combinations through the API by simply rotating your IP address every 1,000 guesses. And at Bumble, interesting example here, not only could you access your information through the API, which was legitimate, you could modify your information. So not only do a get method, you could also do a put. And you could turn on all premium features for yourself and all of your friends. So an example of function level authorization, right? There was no need for a user to have the put and post method on that API. So I want to scoot ahead here and kind of share a real world example of how an organization, in this case Seismic, how they actually have made API testing part of their security and development process. So if you don't know Seismic, a fantastic company. They're really the leader in sales and marketing enablement. So really, the platform for training and enabling your field. And of course, as part of that, their service is going to hold and contain highly confidential information of their customers and their users. The challenge here is, of course, as any modern company, they were looking to add more and more API support and to make those APIs accessible to customers and partners so that they could build their own workflows and custom integrations and the like. And customers were starting to ask, what are you doing to keep my data secure now that you're making this all accessible through APIs? So what they did was deployed our solution, AppySec, into their staging environment. So very much a shift left model. So as new releases go into staging and through their build pipeline, they're automatically having those APIs evaluated by AppySec, where we do automatic creation and execution of thousands of attack playbooks, right? Designed to detect any new vulnerabilities, any new logic flaws, anything that can allow data to get accessed or leaked out through the API. Giving them ultimately a fully automated and continuous API testing capability. So this program runs on every release, not once or twice a year with the pen test cycle, but on every release, constantly updating the playbooks and making sure that any new code gets evaluated. And this quote from Tim, their VP of Information Security, really sums it all up, right? When their customers ask them what are they doing to protect their data, they can show them, right? They show them exactly what they're doing with AppySec to make that information secure. So one quick slide on how our platform works. I'll actually do a mini demo and we'll get into the Q&A. So please keep the questions coming in. So basically what we do is really these three things, right? We have an analyzer component, which is basically going to dissect your API down to each and every endpoint, every call, every input parameter, all the methods, and really understand the inner workings of your API. That's going to inform our engine on how to attack it. So we have this attack generator capability, which applies hundreds of different attack scenarios from things like, can user A access user B? Are there unsecured endpoints, incremental IDs, rate limiting issues, sensitive data exposure, injection type of attacks, really this gamut of attack scenarios, which it then maps onto your API and your logic, your structure, your taxonomy, and really custom generates these attacks to tailor-made to your API. And then lastly, the scanner, which is what actually executes these tests, looking for anything unexpected. If we're looking for some sort of denial, but we get a 200 response instead, we know we've tripped across some kind of vulnerability. And lastly, it's an extremely easy technology to live with. We call it zero touch, meaning no source code access is required. You're not going to find these types of vulnerabilities by scanning through code. You really need to test a live functional API. Nothing to install. So there's really, this platform simply acts as a client interacting with your API, and nothing in line, right? You don't have to fork all your traffic and haul it over to another service. It's not going to sit in front of your API. It's really simply just another client interacting with your API, except that the vast majority of our clients are deploying this capability in a pre-production environment so that you can identify these vulnerabilities before they ever go live. So let me show you what that looks like just real quick in a, just make sure I got the right window here. Hold on. Oops. All right, that's the wrong window. Hold on. Let me close that. Here we go. All right, so here's the AppySec interface. I'm really going to blast through this. Each one of these is a separate API. First thing we're going to do is decompose it into its functional capability. So every endpoint is identified, every method. We're looking for input parameters, right, that we can now generate tests. You'll see here our 100+ categories of tests, all mapped to the OWASP category. So these are OWASP number 1 tests, here are OWASP number 2, and so on and so forth. And what we'll do is take those categories and map them onto your endpoints to generate playbooks. In this case, over 1,200 different playbooks identified or custom generated for this particular API. The key point here is that you don't have to create all these tests, right? The platform is going to do that for you. And what we'll do is run these tests, which can be done manually on a daily scan or through a CI/CD integration, and find the vulnerabilities. In this case, 73 vulnerabilities identified, which are all listed here. You see which endpoint, OWASP category, severity score. And just to show you how sophisticated this automated testing can be, let's look at exactly that US Postal Service scenario, right? What we call an attribute-based access control test, or BOLA. We're going to give you a lot more information about that vulnerability, all right? How it's, description of it, the severity, the impact, including remediation. And since this is APIs, this is machine-to-machine communication, we can give you the exact replay of the entire attack. In this case, this is a multi-step playbook. So it starts with targeting this endpoint called transfers as user A and posting a new transfer. That's all normal. We get a 200 response, and we even get a transaction ID returned by the API. But in step 2, we're going to come back to that endpoint. We're going to append the transfer ID that we got in the first step, and we're going to try to delete it, but as user C. So classic broken object level authorization type of scenario, right? User A created the event. User C now is going to try to delete the transaction. Our assertion, the expected response is a 401, 403, or something like that. And what we actually got back from the API was a 200, meaning this was a successfully executed deletion command. No possible false positive here. We have proven that user C was able to authenticate and then delete a transaction belonging to user A. Just one specific example out of thousands to highlight that, yes, in fact, you can automate this level of sophistication of testing with AppSec. So I'll flip back to the webinar here, the slides. I just want to wrap up, invite folks to continue to share questions here. The book I highly recommend. It's now available on No Starch Press. So if you just look up Corey Ball and hacking APIs, I'm sure you'll find it. We'd love to share a copy with you if you're interested in booking a meeting with AppSec and getting a demo for your organization. We also offer free assessments. So if you have an API you'd like to have run through our platform, we welcome you to do that. You could simply go to appsec.ai/free test, where you can actually submit your API. We'll run it through the platform. We'll cover it with all of our tests, covering all of the OWASP categories. We even now have a new test identifying log4j exposure through your APIs. Highly recommend you go visit Cecil's website, cisoxc.com, and be a part of his community as well. Cecil and Corey, I really appreciate it. We do have a handful of questions here. So there's a lot of people asking for copies of the slides. So here's a question. Are there a lot of false positives? This is a great question, actually, Devin. Like anything, there can be false positives. For example, we might uncover unsecured API endpoints, right? We're going to flag all of those endpoints for you that are unsecured, require no authentication. Now, maybe that you have those API endpoints unsecured intentionally, which there's a very simple way to simply mark that as such, and you'll never, see that false positive again. The alternative, though, of doing sort of, live traffic monitoring is far more prone to false positives and to false negatives, where, if you look at, like, why don't WAFs, identify and block all of these types of vulnerabilities like the Postal Service and Venmo and the like, there's very little context in a traffic call, right? There's a URL request, and how can you really truly identify whether that's legitimate or not? And that sort of goes back to, why it's so important to do that testing, as Corey pointed out. We got another question here. I'll send this to you, Cecil. As a CISO, how do you work with development teams to embed security into the development process?
That's so hard because I used to be a developer many years ago, and we don't really like to work with other folks, but it's really a partnership. I'm trying to do that at the company I'm working for now. I just started there 10 weeks ago, so it's really about partnership. Developers and security, they don't really like to, work together, but I think we have no choice. We got to sit down with them. And I think highlighting the risk to them and the eventual downstream to the organizational risk, I think we have to show them, hey, this is really important to the organization. And I think it's also important for our leadership to connect to our development team. I think they need to be uh, at least, our leadership needs to be aware of those things. We need our developers to be empowered. So I think the partnership and the exposure to upper management needs to be there.
Yeah, yeah. No, we hear this question a lot from clients. There's really a collaboration that we need to see happen between security and development, especially considering how APIs are, not updated once or twice a year, and not just the APIs, but the applications are being updated once or twice a week or a day. We'll take one more question. A lot of folks have asked if the slides are going to be made available. Absolutely. Please just hit me up, Dan at appsec.ai, and we're happy to make them available, as well as a recording. Questions about how to get the book. So a lot of interest, Corey, in your book here. And a question for you. We'll make this the last one, because I want to be mindful of your time and everyone else's. As a pen tester of APIs, what are some of the most common issues or vulnerabilities that you see in the real world?
Yeah, real world, it's going to come down to authorization issues. Those are just so common. When you're pen testing an API, that should be one of the primary focuses to test for that, because it is all over the place in one form or another, which requires, figuring out the resource IDs that are in use, creating resources as one user, user A, and then trying to interact with those however you can with user B. And then the other thing that could add a challenge to that is if, maybe they're protected, maybe there are authorization checks in place for a certain endpoint, but you find different endpoints that can also interact with those resources somehow. And that will lead to both of those authorization vulnerabilities, broken function level authorization and broken object level authorization. Besides those, business logic flaws are everywhere. And you can actually find those, just by looking in API documentation. So if there's any part of the documentation that says, please don't do this, if that's not enforced on a technical level, then that's, a business logic flaw just from reading the docs. And so anything that's based on trust or based on, being told not to do a certain thing, those are going to be inherent flaws that need to be implemented on a technical level.
Yeah, these business logic flaws are almost like your own personal 0 days, right? They're never going to appear on a CVE report. It's unique to you, right? And I think to your point about the fancy hacking and how APIs kind of bypass all that. If a hacker can find a loophole in your business logic, there you go. You've now got access to all those crown jewels. So with that, guys, I really appreciate you being part of the session. We had a really tremendous turnout, lots more questions. So everyone who asked a question, I promise we'll get back to you individually. And everyone who wanted copies of the slides, we'll make sure you get them as well. And please, follow up if you're interested to learn more. And with that, thank you all and have a great rest of your day. Take care.